Good evening, everyone.
Good evening.
A very pleasant afternoon to you. How are you doing today's class?
Afternoon, sir.
Good afternoon to you. How are you today? And the rest of you?
Sorry, it's my message. Good afternoon.
Afternoon, what message is that?
I sent you something in the chat.
Oh, yeah, man. I responded to you too.
Oh, okay.
Mhm.
Sorry, what you sound so?
Oh, no,
Tell me,
no,
let me
good.
beat them up for you.
No, man. So I had a very late class that I teach almost every night. So I had a class up to 9 o'clock last night, and I had a report that was due yesterday, and it took me all day today. I mean, it's like about 4:30 that I submitted the report, and I said to myself, look how I'm tired, and I got go into my best class for the semester, tired. So that's the reason I'm vexed, because I wanted to have completed the report from earlier so I could just relax and then ready. But I'm good. I'm good. I'm excited for what it is to come tonight. What I'm going to be doing with you tonight is exponential functions, and I'm going to also look at the logarithmic function. So I'm going to.
So this is like our new topic. You really are giving a new topic before you give
No, man, guess what? And Kel, look at this. Look here, Kel. Oh, come on. This is exponential function.
As a be a letter that, you know. A be a letter that, you know.
No, but look at what it is. I just have exponential function
count
right
how
here.
Much number.
And then after that, not even one full page. Then I move into the logarithmic function, right? So it is really not difficult. I just want to talk to you about it. And then I have on screen, let me see if I can share it, because you share. I have on screen a document that I want to pass paper that I want us to look at. So I want us to, we have done this question already. I want us to look at this differentiation. See the ln function inside of it. So I want to show. So this is a quotient. So we should be able to work question part 2 of B for 6 marks. But when I go through the logarithmic function, which is this ln, we should be able to get those 4 marks. It's really not difficult. So I just want to spend a bit of time on that today, just to whet your appetites.
Sure, I don't know if it's me, never see it. But did you send the working out for the mock exam?
I didn't, and I'm going to explain why. And I saw the messages, and I say, you know what? Let me address it when I come to class. I didn't, because not only that you have the recording. So somebody who said, but the recording is there. I was like, wow, this person is thinking like I am. I didn't because if you followed what I did on Thursday last week, you should be okay. It's a lovely group that I have, and based on what I did, I think it would have been best for me not to send that one out. You know, I have to keep the little work. So look at the recording. I have no problem. All the pages for the document would be present in the recording. Go through the recording. I want you to look at the recording. I want you to watch that recording as many times as is necessary in preparation for the after tomorrow. And when I tell you that you're going to be 100% okay,
I download that already still.
Yeah, man. When I said
just come in, where talk last class.
Him say good afternoon. Him say him just come in. Him say good afternoon.
No,
no.
So step away. I was here. I was like the second person here with you.
Okay. Now I'm just saying to you, somebody was asking about the handout for the mid semester, and I said that it would be best if I didn't send it out. So that's why I did not send it out. So I'm saying that what is true is that all the pages for the yes, Mommy B, how you do? All the pages for the handout would have been in the recording. And I was saying
the last class recording?
The last class recording, and that was sent out from the very night, as a matter of fact. Go through it. If you have never watched one of those recordings, watch last week Thursday's recording multiple times, as many times until you understand what was happening in all the questions.
Say no more, sir. Say no more.
Thank you very much.
That's the next word.
All right.
All I'm saying.
If you want, you can leave, because I mean you'll be ready for the exam next week. But I'm moving on to something new for tonight: exponential functions. Now, let me just warn you off with something. And I want you to hear me out and hear me out very well. In one of my groups, I was teaching business calculus last school year, and the students were saying, "No man, sir, you're nice, man." And one student said, whereas that may be true, there's another side to Mr. Shan that you have not seen. If you don't do your work and you don't succeed, there's another side of sir that you will see. And the students in the class said, "No, man, we're not going to see that side." And I said, "Praises be. No, let me tell you something. If you don't want us to get along for the rest of the semester, do the recordings, pass the exam, semester exam next week. Already, I am planning my day on Wednesday, that I'm going to have a light day on Wednesday. On Thursday, nobody can catch me to no work because I'm going to rest, because it's a Thursday night. Me I burn the lamp. Me I sit up until my mark all 20 odd pages. Yeah, man, cross it again, Kelvita. Cross it one more time.
Good evening, sir. Just came in.
Yeah, man. So we're talking about curried lobster and shrimps. No, but I'm saying to you though, if you don't do what I'm expecting you to do, I'm going to be very disappointed. Matter of fact, I'm going to leave that not alone. The recording is available, last week's class. Let's move on. Exponential functions. Now, the exponential function.
Sir, before you move on, this is going to be a part of the exam as well, the exponential function.
No honey bunches. No honey bunches.
Okay, so before you end, just give me the topic that we're going to get.
All right, so for the final time, please to review the recording for last class. I have nothing more to say. I have nothing more to do as it relates to mid-semester. Please review the recording for last class.
Noted.
All right, thank you. So for the exponential function. Now, the exponential function is denoted e to the x. E for exponential. So when I speak about the exponential function, we speak about e to the x. Now, not last year, but the year before, the year when we just went into COVID, my calculus 2 students, I gave them a topic where they could predict the number of cases of COVID virus that would exist after a particular period. Now, what is it that they are doing is using the exponential function in order to do that sort of prediction. Now, let me just give a little background to exponential functions, as I tried to do with the other topics, so that you can have an appreciation of the mathematics and just bring in the mathematics to real life. So for some years ago, long before we had or highways and byways, it was reported that a gentleman was coming down Mount Russell, and he recognized one man who was, begging a ride, and this man had a brethren with him. Don't know if there's any truth to it. I'm just telling you what it is. The lesson that is to come from it. And so he knew one of the men. Both men went into the car, and I don't know what happened thereafter, but on his way down the hill, one or both men decided to rob the man. And, they got a hold of the car, got a hold of him, and they bounded him, and, roll him over into the one of the precipice in the caustic soda. Now, caustic soda is very corrosive, and pretty much his body was dissolved. All that was left was his bones, his skeleton. Every bit of his skin was dissolved in the caustic soda. His internal organs, the whole works. All that was left was his skeleton. And people were able to find, people saw what was happening, and they found, tracks. And when the investigators went, they indeed found, the corpse, the skeleton that still had some wire, wrapped around it. So they did something that is called radiometric dating. Why am I telling you this? Because you guys are in computing or computers, and at some point in time, you may end up getting a job with the FBI, or you may end up getting a job with one of the security forces, where it is that you have to help with the analysis of these investigations. And they did some what they call a radiometric protein testing on his bone, and they were able to positively use his dental record to identify him, that this is John Doe. And they did radiometric dating to find out exactly the time that he would have died. Yes, I did say the time that he would have died. So whether or not, I saw where the United States of America recently flew home one of their veterans who died in 1941, I believe the report says. And they flew home the corpse. Now, how would they know that this is that person? DNA, radiometric dating. So they did that and was able to positively identify this John Doe here in Jamaica, and was able to say that he died 2 weeks ago, 3 weeks ago, whatever the situation is, and it was around about that time to the T when he went missing. No.
How long ago was this, sir?
Say that again?
How long ago was this?
It was quite a number of years ago. I remember when I was teaching CSEC chemistry, I used to reference this when I'm speaking about my radiometric dating. So it was some years ago. You can do a Google search to find out exactly what it is. The story may differ a little bit because it's been a while, but the main point of the story that I'm telling you now is there's something that they call half-lives that they use to tell how long the person would have died. These half-lives are exponential graphs. So they have these exponential graphs that what it is that they would do when they put a sample of the bone into to do the sort of radiometric dating, based on the deterioration of the carbon counts in your system, it gives you a particular graph, right? And that graph, because that graph now you can compare that graph to well-known graphs. Put it this way. So quite a number of you are parents in this group. And if you're not parents, you would have had, maybe to take a child to, for prenatal or care or whatever it is. And when the doctor is trying to assess the development of your child, the doctor may say, look at it and say, take measure and measure the child's head. They will take the weight, they will take the length, and sometimes you see they flip into a book and look at a graph. And they will say to you, well, Mom, the child is developing normally. No, because it means that the child, based on what it is that they've plotted, they look at it to say, yeah, man, the child is developing okay. Now, when they plot it and they look at it and the child falls beneath the graph, then it forms some levels of concern because the child is not developing at the rate at which the child should develop. If it is over the graph, the child is overdeveloping. So they may look at you and say, okay, fine, mother, were you on steroids when you were pregnant? So which is why, and a lot of things happen. So which is why, and I mean, we're adults, we can talk about things, which is why sometimes you may see an 8-year-old who has begun to see our menstrual cycle, because it is that maybe the mother was on steroids because of the difficulty in the pregnancy. So the child starts to grow pubic hairs earlier. The boy's voice may get deeper at age 7, sounding like a teenager because of what has happened. So the doctors can look at these things and predict what is happening. So the point I'm making is in the medical fraternity, they use graphs to predict normal growth rate. So they also use graphs to predict the time of death by using half-life graphs. And these half-life graphs are what we call exponential graphs, right? So when you look at these exponential graphs, we can say to you that we can match these exponential graphs from the radiometric dating. And if you want, out of interest, you can Google radiometric dating and you can read around it to see exactly what is happening. And you can even put it in your phone or whatever it is that you're doing right now while listening to me. And you can have a look at what some of these half-life graphs look like. And so when they get the information from the system and they put it, they will say, they will match the half-life graph with pre-existing half-life graphs. So they will say to you, this person died 48 hours ago. And it is as accurate can be. And they use this a lot in forensic science. And just by extension to say to you, the course that it is that you're studying can actually take you into these areas. So you become a forensic scientist in computer auditing. Some people who delete information from the computer, if they say they might tamper with evidence, going to go into that sort of forensic science. So it is that you can find the memory and bring back some of the stuff because it is written somewhere else in the something down there, so that I only know about that I don't know about. All right. So they use a lot of technical experts to do these sort of analysis. These are the exponential functions. These are exponential graphs. I can, as I said before, predict how many persons possibly would die from COVID, putting in some things in place for things of this nature. So it is that you can do and get some sort of rough estimates. So this is what in general the exponential graph looks like. So you may say, sir, why am I learning this? And which is why I'm giving you just a snippet of how it relates to your course, because you may say, sir, I'm studying computers. Why on earth I have to learn about exponential functions? Now I told you why it is that you're learning about exponential functions. None of you knows where this life will take you. You may believe that you're going to own your own business, but an opportunity comes and you're going to fall in, and then a bigger opportunity comes where it is that you can work with the FBI. And they said, what is your area of study? And they said, computers. There's a position open here now. We need somebody for forensic analysis, and you know how to do your stuff, and bam, you get big job. But when that happens, just remember that I taught you and I gave you the ideas, all right? So now, we're looking at the exponential functions, and we now have to differentiate these exponential functions. So we will differentiate these exponential functions, and there's also another method of calculus that we call integration, and we will also integrate these exponential functions. Now, one of the good things about the exponential function is that when you differentiate an exponential function, you get back the exponential function. So the differential of the exponential function is the exponential function itself. The differential of the exponential function is the exponential function itself. The differential of the exponential, P-O-N-E-N-T, the exponential function is the function itself. All right. So what needs to happen is you will understand what I mean by the differential of the exponential function is the exponential function itself. Let us look at y. Y is being raised, sorry, y is equals to e to the x. You see me have one x there, but one x is just x. So y is equals to e to the x. Now the differential of e to the x is e to the x. See it here? The differential of e to the x is e to the x. So that's what I'm saying to you. Please note that the differential of the exponential function is the exponential function itself, is the exponential function itself. All right. So the differential of e to the x is simply e to the x. But I want to show you something a little closer. Do you notice that this is y equals e to the 1x? So what it is that we do, we differentiate the function, which is going to be written up top. The differential of x is 1. And this is this one that is seen in front of it. And then you write by the exponential function. What do you mean, sir? Let us look at the second example. Y is equals to e to the 2x. Y is equals to e to the 2x. Now, when I'm differentiating the exponential function, it is the exponential function itself. See it here, e to the 2x. The piece here is the same thing as all of it up here, so. But where this 2 comes from, sir, I'm differentiating the function. What is the differential of 2x? 2. Let us try this one. The differential of the exponential function is the exponential function itself. E to the 3x, watch me, e to the 3x. But I'm differentiating the function 3x. So I'm going to get 3. So that function now becomes 3e to the 3x. So this is why I'm saying to you, the differential of the exponential function is indeed the exponential function itself. Will never change. The differential of the exponential function is the exponential function itself. Watch me here. Let us look at 4. And I'm going to give you a chance to look at this for yourself. Just work with me. Y is equals to e to the x squared. The differential of the exponential function is the exponential function itself. So my answer must contain an e to the x squared. See it here, so? E to the x squared. But what I'm going to be doing here now is to differentiate my x squared. Now, when you differentiate x squared, you're going to get 2x. So that's why I have my 2x e to the x squared, and it finishes right here. Look at this. The differential of an exponential function is the exponential function itself. So what is going to happen? My question says e to the 3x squared plus 5x minus 7. My answer must contain the same e to the 3x squared plus 5x minus 7. See right here, so the piece here and the piece here are the same. The only thing now is that I must multiply it by, just like I multiplied in front of here, so 1. I multiplied here 2, I multiplied here 3, and I multiplied here 2x. I must now multiply it by the differential of the function here. And the differential of the function is going to be the differential of my minus 7 is 0, and the differential of 3x squared is going to be 6x, and of 5 is going to be of 5x is going to be 5. So when I differentiate the function here, I'm going to get 6x plus 5. See it right here, so 6x plus 5. So the aim of this question is, or this topic is, to remember the differential of the exponential function is the exponential function itself. When I differentiate the exponential function, I get the exponential function back. Sir, is there any point in time when I will not get back the exponential function? Absolutely not. Then, sir, it only happens when you do the product rule? It happens every time. The differential of an exponential function is going to be the exponential function itself. So what I'm going to do for you, is to ask you to look back at these 6 examples. You notice I did 1, 2, 3, 4, 5, because I'm going to leave you with this one to try for me. Having gone back through the whole business of 1, 2, 3, 4, 5, I want you to look back at 1, 2, 3, 4, 5. When you would have done that, then I want you to try 6 for me. Sir, who am I going to try 6? The differential of the exponential function is the exponential function itself. Look to see if you see e raised to the 3x squared over x plus 1. Yes, sir. See it right here, so. All you now need to do is to differentiate this quotient. You know how to differentiate the quotient. So go ahead and do number 6 for me. I'm going to see if I can start writing some narratives for you to make your notes taking a little bit easier. So start for me, please. I'm right here. Don't go sleep on me now, you know. When I finish number 6, anybody?
No, sir.
How is it going? Having challenges with it?
A little bit, sir.
Remember, you know, you're differentiating the quotient, the denominator, times the differentiation of the numerator, minus the numerator, times the differentiation of the denominator, all over the denominator squares. So
check that, sir.
We'll do. Okay, so it is correct in parts. There's something else that you're missing off. All that you have there is correct, except that something is missing. Look back at it for me. Okay, Yannick, you're able to get everything there. I mean, everything to the T, honey.
Yes, sir.
Very good. Keep it up. Very nice job. All right, guys, I'm giving the rest of you a few minutes, because what we want to do today, after doing the 6 examples with the exponential function, I want to move into the logarithmic function. Then we work 1 or 2 examples of it, and then we're going to go into the past papers to work those 2 examples, questions that we are seeing there. So we are sharpening our skills. So yes, we're still on differentiation, but I have to include another notch to it, so that, you know, today is not a day that we're just revising. Last week was our revision week for 3 hours. We're not revising anymore. We're moving on. So I give you another 5 minutes thereabout to finish off this. Then I'm going to come back and do the logarithmic function. Spend about 50 minutes on that one, and then we do a few examples that I have, and then we jump into the past papers. And if there is time, we'll go back to some more of the examples I have. All right. So come. All right. Is everybody okay now with number 6? If you're not okay, just let me know, please. If you're okay, that's fine. Is everybody okay with number
sir.
6?
Yes, sir.
Good job. There are quite a number of students that are absent this evening. Is there a mid-semester coming up after this class?
No, sir.
Is there a project that is due? Presentation?
Yes.
No, sir.
Maybe for the other one, them Shani, we don't know. Not for our, not for our.
Not for your group.
MIS. No.
Oh. Normally when I say things like this, it means that they are trying to finish off some of this work at my expense. And I don't like that.
Jermaine, all of these persons are in our other classes.
Okay, so it's a mixed group that is here now.
No, sir. All of them is in our classes, in all our classes.
Oh. All right. Ramesh, you have not been here for quite a while. You were not here the whole of last week. Anyway, good to see you.
I was here on last week Tuesday, I just wasn't here for Thursday.
Okay, of all the days, but anyway, never mind. All right, let's go. So let me ask the question one more time. Are we okay with number 6? Can I move on to the logarithms? Is there anybody that needs help with number 6? Speak now or forever hold thy peace.
Sir,
Okay.
somebody put something in the chat.
Sorry, thank you. I didn't. All right, so somebody said, Matt, given issue, someone say something, please. I'm not giving it as an x plus 1. X plus 1, where, Sean? In the numerator or the denominator? In the numerator. Interesting. All right, hold on, Sean. All right, so I asked the question because I wanted to know whether or not I should be doing the question. And let me just write in this case as opposed to type. Let me write pretty quickly and see what happens here. So the question is, why my computer, it has a mind of its own. Jesus. So the question is, what's the question? Y is equals to e to the x cubed? No, 3x squared over x plus 1. So remember, what is happening here is I'm going to differentiate my quotient. My quotient is a denominator. So my dy by dx is going to be equal to the denominator, which is x plus 1, times the differentiation of the numerator. When I differentiate the numerator, 2 times 3 to the base 6, I'm going to get 6x, times the numerator, 6x, minus the denominator, which is x plus 1, minus the numerator, oh Lord Jesus, help me. The denominator times the differentiation of the numerator, minus the numerator. So I'm supposed to be subtracting the numerator. Minus the numerator. Minus the numerator, which is going to be 3x squared, times the differentiation of the denominator, which is going to be times 1. All over the denominator squared. So it's going to be x plus 1 all squares. This works out to be 6x times the denominator times the differentiation of the numerator. The denominator, x plus 1 times the differentiation of the numerator, 3 to 6x.
6x squared, sir.
Say it again. What's my question?
Wouldn't that be 6x squared minus, well, not minus, plus 6x?
Oh, yeah, man, that's where I'm at. Yep, so right. Yeah, man, you're correct. So it's going to be 6x squared plus 6x minus 3x squared minus 3x squared. So what I'm going to get is the denominator times the differentiation of the numerator, 3 to 6x minus the numerator, 3x times the differentiation of the numerator. Right. But I was just checking something. Over the denominator squares is going to be equals to x plus 1 all squares. That works out to be 3x squares plus 6x all over x plus 1 all squares. And then in all of this, I can factor out a 3x. So that will be x plus 2 over x plus 1 all squares. So therefore, my final answer is going to be 3x times x plus 2 all over x plus 1 all squares, e to the 3x squared over x plus 1. So this is what dy by dx is equals to. Question? Clear now?
Yes, sir.
All right, good. Then, sir, do I have to factorize the numerator? If you left it at 3x squared plus 6x, I still did the math, but we try to factorize because we don't know if there's anything in the denominator that we could cancel out, as you would have seen us do for the quotient ones in particular. All right, so Sean, thumbs up if you're with me, thumbs down if you're not.
Sir, check your WhatsApp messages.
Okay, thank you. Okay. Yeah. Yeah, but that is a. All right. Let me send you something. Send something. Hold on. All right. So so let's go. The logarithmic function. The logarithmic function. Now, just like how we differentiate the differential of e to the x is e to the x, times, of course, the differential of the function. The differential of the logarithmic function is going to be 1 over x. So the differential of ln x is 1 over x. The logarithmic function ln x, this is a logarithmic function, ln x. The differential of ln x is 1 over x. Sir, what do you mean? The differential of the ln function is 1 over x. This one is a 1 in front of this x. When you differentiate it, you're going to multiply by the differential of it. So the differential of ln x is 1 over x. All right, so that's given. So let us try and differentiate ln 2x. It's going to be, differential of the function is going to be ln x. And then I'm going to times it by the differential of the function. So let us look at this one here. So let us look at, let me get a different color so you don't. So if y is equal to ln 2x, dy by dx, the differential of ln x is 1 over x. This x is 2x, sir, right? So the differential of ln, this is a function. The differential of ln x is 1 over the function x. But in this case, it's 2x. And then now I'm going to differentiate this piece, the same piece that I just highlighted. I'm going to differentiate it. When I differentiate 2x, what do I get?
2, sir.
I get 2. All right. Something is wrong with number 2. I made a mistake somewhere. So the differential of ln x is going to be 1 over x. So when I differentiate this 2x, I'm going to get 2. So it's going to end up being 2 over 2x. And of course, the 2's cancel. So I'm left with 1 over x. So that's supposed to be 1 over x and not 2. Right? And then when you look at the third one, y is equals to ln x plus 1 dy by dx. The differential of ln x is 1 over x. So it's going to be 1 over whatever x is, x plus 1. And then I'm going to times it by the differential of the function. I have to times it by the differential of the function on the inside. That is a function piece. When I differentiate it by x plus 1, I'm going to get times 1. So dy by dx is going to be equals to 1 over x plus 1. All right? So, so that's what the differential of the logarithmic function is. The differential of the logarithmic function is just 1 over x. The differential of ln x is 1 over x. But remember, if you are given anything greater than just x, as in this case, you'll have to differentiate inside here. Just like when you have to differentiate this 2x to be multiplied by 2, that's what you end up having to do. All right? So the differential of the function ln x is 1 over x every single time. The differential of the function ln x is 1 over x. And that's all that there is to it, and which is why I left these two things for now. Because in summary, the differential of the exponential function is the exponential function itself times the differentiation of the function. The differentiation of the ln function is 1 over the function times the differentiation of the function. All right? So the differential of ln x is 1 over x times the differentiation of x, which is 1. So when it times 1 by ln x, you get ln x. All right? The differential of the exponential function is the exponential function itself. But remember, you have to differentiate the function now. And that will be it. All right? Now, what I want you to do for me, I don't want you to see the solution to this question, because this question looks very similar to what it is that we did earlier. And I want to make sure that you guys grasp what it is that I was talking about. And as such, hold on there. Over here. And as such, I want to see you guys try for me. Oh crap. This piece is going to go all the way down because of what, it will come back up. I want you to try this differentiation for me, please. Differentiate y equals e to the x squared over x plus 5. Y equals e to the x squared over x plus 5. This differentiation, again, guys, will help you with your different rules or forms of differentiation. You'll get product, you'll get quotient, you'll get chain rule, you'll get power rule, you get all the different rules when you're doing this level of differentiation. So start for me. I'm giving you about 5 minutes. I want you to take your time and just digest this this topic here.
Good evening, sir.
Hello.
Seems as if I miss a lot of things, sir.
Of truth, you know that when you come to my class, we start. I give you about a 15 minutes break just to get settled in. Um, and then we hit the road running. So what we looked at was just the differential of the exponential function. And we are now looking at the differential of and we have also looked at the differential of the logarithmic function. And what we are now doing is some combined questions involving both exponential and logarithmic functions. So really and truly, the differential of e to the x is e to the x, and the differential of ln x is 1 over x in general.
Sir, look like I have to go watch this video.
And you'll be fine. When I'm doing the solutions to this, you will be perfectly fine, Sash. You fret not.
Okay, sir. Sir, I wanted to ask you to do something for me, but I'm late, so that won't happen for now.
What happened?
I realized you didn't work out question 8 on one of the differential worksheet.
Mm-hmm.
And I was trying to do it, but I didn't understand how to get it done.
Question 8.
Yes, sir.
Good day, sir. We're supposed to do which question?
The example one here. Sash, take a picture of it, please, and send it to me in WhatsApp so I can have a look at it. Thanks.
Sure.
Krishna, this one here. We're doing this one now.
Okay.
You just joining?
Yes, sir.
You may have a problem then. Do me a favor, because this is an exponential function. So
Mhm.
do me a favor, just differentiate x squared over x plus 5 for me, this quotient, x squared over x plus 5, and then I'll tie it in for you for the final answer.
Okay.
Sent it in the group, sir.
Okay. All right. Is there anyone that has completed the question?
Yes, sir.
Nice. Anybody else?
I think so.
Good. Good. Come on, Ryan. I always send the documents at the same time. So you don't have to worry about it. Oh, sorry, Shadi, you saying somebody. No, Chelsea, never mind. Someone else. Okay, well, I did the solution on this, all right. Okay. Talk to me. I just heard Yannick and I heard Jeremy. Anybody else complete the stuff? What is wrong?
Sir, I said I was finished, sir.
Okay then. All right, cool. And who else? Andrew, what going on? Ryan. Oh, Ryan is still driving home. Nestor, you silent to Nestor? All right. Let me walk you through this question, because when I hear the silence like that, it's concerning for me, because it means that you guys are missing something. Now, the answer looks very ugly. Fret not about the answers. Looks very ugly, but let us walk you through it. The differential of e to the x is e to the x. The differential of e to the x is e to the x. Oh, sir, that's why I have this e to the x right there? Absolutely. So the differential of e to the x is e to the x. Can't change. Cannot change. The differential of e to the x is e to the x.
Sorry, can I explain that?
Sir, that's why you must write the answer. I thought the function was supposed to be on the outside.
Yes, 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 Charles. No, but hold on there, no. Remember, no, you thought this function right here is supposed to be out here, so that's what you're saying?
At the end of it, sir, because that's how I see you have it in the others.
No problem, because remember, if it's at the front, it means that it's being multiplied. If it's at the back, it means that it's being multiplied. Same difference.
Okay,
Okay then. All right.
There's a commutative rule, law, something like that. Primary school maths.
It is associative, because you're multiplying, right? So 3 times 2 is 6 and 2 times 3 is 6. Yeah, the associative rule. Very good. A long time ago, do them something, you know, so have to think back to where I asked about a while ago. But yeah, that's something there. You did learn at a school, little school? Well, when you're young, because me learned at a big school. All right, let's go. Charlie, don't pay them I love it. All right, let's go. So it's the differential of the exponential function is the exponential function itself. All right. And then now we have to differentiate up here. So Krishna, teacher was saying to you, no worry about the piece here, just worry about differentiating the exponential function. The denominator, see it right here, so x plus 5, times the differentiation of the numerator. The differential of x squared is going to be 2x, see it right here, so minus the numerator, minus x squared, see it right here, so times the differentiation of the denominator. When I differentiate x plus 5, I'm going to get 1 all over the denominator squares, which is x plus 5 all squares, see it right here, so technically the question done right to say no, but I'm going to fix it up, right? Nice little fixer up. 2x times x is 2x squared. 2x times 5 is 10x. Minus x squared times 1 is minus x squared. And that's why I'm fixing it up. My x plus 5 all squares I will not touch. I will leave it alone. So when I subtract this x squared from 2x squared, I'm going to be left with x squared plus 10x over my x plus 5 all squares. I notice I carry back this. I carry back from the question to here, so to here, so to here, so to here, so it not change. The differential of the exponential function is the exponential function itself. And then I can factor out something to make things look a little nicer. So I'm going to say x times x plus 10. See there? X times x plus 10. Voila. Did anybody get that one?
Yes, sir.
That's good for that.
Very
Yes,
nice.
sir, I got it.
Very nice. Very nice. Excellent. Excellent. Is there anybody that is still a little puzzled as to how we got to that answer? Speak now. Speak honestly. Be true to yourself.
Yes,
Now
sir.
watch. Yes, Robert Krishna, you just joined. All right, you got the differential, Krishna, of the quotient.
Yes, sir. But I just the one. Where did you get the one again?
Which one? The one here?
Yes, sir. How
The
did you get?
differentiation of the denominator. Remember, it's the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator. So when we differentiate x plus 5, we're going to get 1.
Okay. Okay.
Right. So we have to make sure that that happens. Now, if you don't use it to lose it, if you don't use it to lose it, so here on out, having completed differentiation with you, what we're doing now is those different types of differentiation. For the remainder of this course, everything that you get is going to include differentiation. So it means that by the end of the course, nobody should not be able to differentiate. And by the end of the course, nobody should not be able to integrate. Because here on out, and matter of fact, I'm going to go back to limits. I'm going to go back to limits. And when I go back to limits, I'm going to even use differentiation to the limits and show you. Yeah, man, it's nice, man. So that's what it is. All right. So having gotten that, proud of you. Here goes another question. This is 6:30. Here goes another question. That question down there for number 2.
Question.
Go ahead.
We're getting this on the test as well.
Mm-hmm.
We're getting this on the test, Thursday test.
No, sir. What I would say to you is look at the recording for last Thursday. Last Thursday's recording will give you an indication as to the areas that we're going to be covering or will be covered. All right. Now, if you look at this one here, what can you say about this question? It involves a what? What rule do you use for this one?
Power rule, sir.
Is it power rule? That's what you want to
Product, sir.
No,
Product. Right, you
Product.
have to use a product. Remember, the power rule is when it's raised to a power, you know.
that look like stress.
It looked like
So-
stress. All right. So
I
if
thought
you
it was raised, sir. I thought the E was raised.
no, man, that's fine. That's fine. That's fine. No, it's not raised though, but that's fine. Sash, you sound like you're out of it today. One to you, Sash. Talk to teacher. You all right?
Sir, I'm reach late, so I'm just.
Reach
Don't worry
late
about
and it's look like say fly gone on Mars and come back and come back and come back again.
No, man, we're good, man. Kelvita
Sir, I'm
loves to see
using
these
my
things.
phone, so I have to be zooming in and stuff like that.
Oh, you can't see. So you must ask me, sir, bigify something for me now, sir.
No, man, I'm going over to my laptop. I'm waiting on it.
Oh, no, man. Ask her to bigify it, man. I can bigify it for you. All right, let's go. Start that for me, please. Yes, so it's going to be the product rule. So I'm giving you 5 minutes. When we finish this one, We're going to run to the past papers, and then if there's time, we'll come back to Sir's examples. Start.
Sir, that one look like it need to eat dinner and then come back.
Behave yourself. There's nothing wrong with the question. It is very nice.
Sir, did I try a thing, you know, sir?
I want to do, but you laugh.
Sir, may I try a thing, but the E thing, me I know what I'm going to feed, sir, so.
So should I ignore the E?
No, you can't. You can't.
The E thing I threw it off.
The differential of the exponential function is the exponential function itself. So you can't
So
ignore it.
instead of thinking that kind of mix up with the
It means that you're going to write it back. So you can't ignore it, you're going to write it back.
Jermaine, it's simpler than you think.
Let me try, sir. May I try? Even though I don't really know what I'm going, but may I try?
Say you're good enough, try it, man. The differential of the exponential function is the exponential function itself. The only thing that you will have to do with the function, with the question now, is to differentiate the function itself.
Mm-hmm.
Yeah, man. Go on work, man. Go on work. I'm here.
It's look weird. See, if me get this, sir, me need a shrimp meal.
That's all. You can get lobster too. Ryan and Drumming in peace, though.
Sir, don't mix me.
I love it. Yes, I am. It's all these people who sneak into the class and don't even say good afternoon, like Chedi and Lexton and Nika. You know, long I'm waiting on Uno. Exponential function.
Sir, I finished, sir, but I don't know if I foolishness.
If we get this right, man, turn Christian tomorrow.
Oh, Jesus, Lord,
Oh,
bless his heart.
Jesus, Lord.
Bless his
Bless-
heart, Lord. Bless his heart, Lord. Jesus.
You hear that,
It
Shirley?
says, heaven will
Hear
rejoice.
him.
Heaven will rejoice when one sinner enters compared to 99 righteous. Mm.
Jeremy, not that. Heaven
Don't
must
get
have
me
party.
started. Don't get me started, Jeremy. All right, I'm gonna put something here for you.
Sir, make Jermaine talk about him answer before you show it.
Are you saying that you don't trust Jeremy? That's what you're saying?
No, no, sir, may I say?
Jeremy, you need wants to hear your
talk
answer. She wants to hold you accountable that you're going to you're going to become a Christian. Jeremy, what's your answer?
Wrong, mom, get negative 30 over 7x plus 1 square. Definitely wrong.
Bossy, and I want quotient to know. Oh, you get that?
See? I got to like Christian then, so.
No, man, I think you may need to become a Christian and then you get a question right. All right, let's go. Krishna, I want you to pay attention to this, Papa. Sash, you need to pay attention. Lexton and Chedi, you need to pay. Where's Davio?
Let's get Yangan. Yannick?
No, man, Yannick,
But we never factorize it.
Oh, I never put the 7 out.
Same, sir. The last one, them in a but my day. Have everything else.
Where's Davio? No, I'm going to. All right.
Meaning I didn't do it all, sir. Do it all, sir. Separate them. So I have 14x minus 26e.
You put the 14, you put this before this?
No, I'm saying they're combined.
Oh, yeah, 14x e to the 7x plus 1 and then minus 26 e to the 7x plus 1.
Oh, that means I'm answer wrong, sir.
Don't worry about it. I love the energy and the effort. Let's go. So you have a product. You have a product. 2x minus 4 times e to the 7x plus 1. Trust me, it's something like this the man them being fling pound on the exam. Don't have to worry about it. Sir has taught you the product rule. The first times the differentiation of the second plus the second times the differentiation of the first. Fret not, it will never change. That rule that I give you will carry you through calculus 1, calculus 2, and calculus 3. So you don't have to worry about nothing at all. The first times the differentiation of the second plus the second times the differentiation of the first. Watch me. I am calling one my first, one my second. So I'm calling this a first. So this is a first, I write it back. Times the differentiation of the second. The differential of e to the x is e to the x. So therefore the differential of e to the 7x plus 1 is going to be e to the 7x plus 1. I write it back. And then now, I must now multiply by the differential of the function. And the differential of 7x plus 1 is 7. That's why that little 7 each up right here. So let's go again. Somebody didn't say that. Come. Pause the piece of chicken. Come, Ryan, leave the chicken alone, man. Too crazy. Come, let's go. It's a product. It is a first times the differentiation of the second. And then it's going to be the second times the differentiation of the first. So it's the first, bam, times the differentiation of the second. Now, what Sir said to you, Ryan and Sash, when you weren't here, what Sir said to you, when you are differentiating the exponential function, it is the exponential function itself. But we have to differentiate the function up top. So the differential of e to the 7x plus 1 is e to the 7x plus 1. See it right in here, so. And then now I must differentiate the 7x plus 1. And when I differentiate the 7x plus 1, I'm going to get 7. So it is the first times the differentiation of the second plus the second. So I'm going to put back plus this. And then times the differentiation of the first. So when I differentiate the first, I'm going to get 2. Why I have this in blue? Because the differentiation ends right there. We need to fix it up now. So if you have this line, you're going to get plenty enough marks. And then just to fix up it down here, so you're going to have a little bit of marks distributed because you would have done most of the work up here. Watch me. if you look closely, this 7, I am just putting it in front of here just to make it look all right. So technically what I'm doing is just rearranging this 2. I'm just putting it in front of here. So now you understand this line. Do you have to write this line, sir? Maybe not, because you could see now that there are 2 terms. You know why I want to do it? Because I also want to remove these multiplication signs. So let us keep this line. So there are 2 terms. This ugly looking something right here is 1 term, separated by my operator, my plus sign right here. And then this little small looking thing here now is going to be the second term. So what I'm looking for is to see what is common in the first term that is common to the second term. And the only thing that is common is going to be e to the 7x plus 1. I take it out. And then I'm going to ask what is left. Now, if I take out e to the 7x plus 1, what is going to be left is 7 times 2x minus 4. See it yourself? 7 times 2x minus 4. And if I take out e to the 7x plus 1, bam, what is left is just going to be the 2. So see the 2 right here, so this factorization in this question is pretty easy. Now I'm going to be fixing up what is inside these squared parentheses. 7 times 2x is going to be 14x. 7 times negative 4.
Sir,
Go, Cherry.
what is the reason you said why you put the e to the 7x plus 1 at the front there?
Because it is common, so I'm factoring it out.
Okay.
Yeah, man. So I'm going to say no, 7 times negative 4 is negative 28, and this plus 2 stands alone. So I never multiply the 7 by the 2. You have a separator here that bars it from this 7. So this 7 can't touch this because of this. So I'm going to write back my plus 2 here. The 14x stands alone, and negative 28 plus 2 is negative 26. And you just combine this to that, and that's your final answer. Question. Somebody not seeing something. Question.
Clear as mud, sir.
Say it again, Sash. Oh, it's clear as mud.
mud.
Yeah, got you. Ramesh, Nestor. Talk to teacher, no, Nestor.
Sir, may I struggle, sir?
And that's why I want. Why it is a calling upon you, Nestor? Nestor, why it is a calling upon you?
And I don't try to get it, sir, but it takes too long to calculate everything.
But don't worry about it. What I don't want you to do, Nestor Boo, is to sit in class and get frustrated. All right. This is not necessarily for you, Nestor. This is for the class as a whole. Many of you, I didn't say all of you, but I can guarantee you, many of you in this class would be the first in the family that is going to get a degree. If you're not the first, you may be the second or the third. But many of you, and if you look back at it, would be the first to get that. Maybe mommy or daddy or auntie or uncle not have no degree. Me now, so them can't read and write, you know, but we're talking about a degree. All right? What's the point I'm making, sir? Where are you going with that? Many of them, and even if them have a degree, they may have a degree in a history and them something there, them can't help you with the calculus 1. So when you leave sir class, very confused, when sir is not here to straighten out the confusion, you're going to be left frustrated. You're going to be left frustrated. You're going to have a dislike for calculus 1. And when you start hating something, you're not going to put out as much energy in it because you're going to already say it don't make no sense because you already failed the course and you know it's just doom and destruction for you. Don't let that be the case for you. Don't let it be the case. If you're not following, it's so many times I ask the question, are you understanding? And keeping the class not telling me, sir, no, I'm not understanding. But is it true me no send me a teaching long time? Me knows that not everybody in the class will follow. Some of you seen the screen, but you're not seeing the screen. And let us get real frank. Some of you reach home like a night like tonight and say, Jesus, Father, oh, me reach your work tomorrow, me not no money. Or me reach home and Jesus, sir, I have class, no class, soon finish, I have an next class, I have nothing to eat. So the struggles are real. I understand them struggles, they know. I really understand them struggles. And that's why I think I am the teacher I am today. But let me tell you something. I don't care if you don't have no money for paying the school fee, or you don't have no money for eating no food, or you don't have no money for go to work. What you're doing here is going to cause betterment of life. So whatever you have to do, you're going to do it. So all if you're not hungry, you go and buy some tea, you put no sugar in it, bust 2 gas, and ready to go. When I mark my paper, students, nobody's to fail. I don't like to see the C minuses, but I better not get one C minus and get a D plus from here.
Present, present.
So I'm going to say to you, what is important, students, what is important is that you're going to be honest with yourselves. When I ask the question, if you are understanding, just be honest with me, no man. Because if I ask the question, if you're not understanding, I'm going to say, okay, now understand, I'll move on. But because me know, I sit down and I say it several times. Because we know somebody in the class. Now I catch it. But talk to me, man. I am not going to say to you, oh, you don't understand this and look how long me I do it. That's not this teacher. Matter of fact, we don't have none of those teachers at the college. All right?
Sometimes when I don't understand, because
Barrett, you're very low. Something about understand?
yeah, when I don't understand what I normally do, like last night, I sit down and go through the question because I was struggling with differentiation, and I sit down last night and I work it and understand because I was struggling with the part where you had the recall thing, and I realized that all I needed to do is just put that in the equation instead. I didn't understand why it was working it, and that's how I normally work learning. Just go through it by myself. Sometimes I'll be in class. Honestly, me last, but me didn't really want to keep on nobody. But go back and sit down and do it after, and then me get it. That's how me get it. I work it multiple times.
Very good. So what you use the recording to help you?
Yeah, that's why I'm always ask for them, the recording and the practice questions. Yeah, where you work out.
Very good, sweetheart. And that's the way to go about it. You know, and it's me trying to motivate somebody here today. It's one of the things that, as I said to you, I was working on a report that I sent off to my team members. I don't say nobody respond to me yet, but it have to go up tonight. I'm saying to myself, what happens when you go back to the face-to-face? You know, the face-to-face, when you done one class, it's done, you know, have the recordings to go back to. And I'm saying some people are bashing this online in a way that it is unfortunate, because the same thing that you hear me talk about now in class, when you're listening to the recording, is as if you're in class now with sir. At any given point in time, or 3 years on the line, you listen to the recording, is as if you're still in class and sir, you know, have him talk to motivate. And this part of the teaching and learning process is very important. Me stopping the class to motivate somebody, because somebody may feel down, and it's not a fact that the person not understanding and care to the maximum. Life is very evident, and sometimes you come to class and have the different struggles. You have to stay at work and work an extra hour because it gives you the overtime, and because you have to work on work finish 4 o'clock, you know, but because you have to work an extra hour now, you have to be in the hustle and bus for come to school, and you miss the first part of class. But if you don't do this, you can't pay the school fee. And that's why I give you guys 15 minutes at the start of the class, because I understand the struggles. So I'm going to beg of you, go through the recording, find somebody in the class. And guys, if somebody reach out to you, don't bash them. Take your time and go through with them, because it's when you explain something to somebody, it causes you to remember even more and understand the topic even better. All right? If you're having a challenge, reach out to me. Reach out to me and say, boy, sir, this is the situation. Others have done it. Come on, I really want you to get it. Anyhow, let's go again. So I want all of you to pay attention. I don't want anybody to get frustrated. Don't get frustrated on me. Please, let's go. So we're using the product rule. So how you know it's a product rule? Because there's something here is multiplied by that something here. So what do you mean by that something and that something? I have two terms. My first term is 2x minus 4. And my second term is 7x e to the 7x plus 1. So I have two terms. One is being multiplied by the other. But sir, the difficulty I have is that I'm not seeing a multiplication sign like what I'm seeing the multiplication sign. In big school, we don't write them sign again. Them sign were left off when you left primary school. So when you don't see no sign here, so but the one each upside of one you saw, like matlock, it means that you're multiplying. Then sir, what it was dividing, you just see something over something. Then sir, what if it's subtracting, you just see something minus something. And adding, sir, something plus something. So it simply means that this is being multiplied. Then sir, we can call this term a first term, whichever you want to call it first term for your business. But I always like to call this one the first term. So this is why I always say start at the front. But if you want to call this one the first term, you get the same answer. Watch me. The first, when we call the first, we write it down. Sorry, I write it down. The first, 2x minus 4, 2x minus 4. This is that because I said the first. The first, present, sir. First is present, so I write it down. Times the differentiation of the second, it means that I have to differentiate my exponential function. Ouch. Forgive me. I do this a lot because when the questions come to me in class and students are not understanding, it is very concerning. So I have to do what I have to do. All right, I don't know if this fits right here, but let's go. The first times the differentiation of the second. The differentiation of the second, the differential of e to the x is e to the x times the differential of the function up top. So because the differential of e to the x is e to the x. So what do I mean by that? The differential of the exponential function is the exponential function itself. So it means that when we differentiate the exponential function, I'm going to write it back. See it right here, so. This piece right here, so, is written back right here, so. Then, sir, each of a plus 7 here because I now have to differentiate the power. I know how to differentiate the power. I know how to differentiate the power. I have to differentiate the power. I cannot not differentiate the power. I have to differentiate the power. Plus the second, so I'm going to plus the piece here, plus the second, right here, so, times the differentiation of the first. Now, when I differentiate 2x minus 4, I'm just going to get 2. So what I'm saying is we can clearly see that the answer is a differentiated power times the given exponential function. See here, the differentiated power. What do you mean by differentiated power? We differentiate the power. So this is the differentiated power times the exponential function itself. Does this make it? Does this help in any? What I have in green, does it help in any way, shape, or form?
Yes, sir. Yes, sir.
Come on. So we clearly see that the answer is going to be the exponential power times the given exponential function. The exponential function will not change. All right. So really and truly, you know, the differentiation ends right here. So in the blue, you know, all that is left here is algebra. So let me just do some algebra with you. All sir is doing is putting this 7 in front of the something. See it right here. So. And then I'm going to say, you know what? Take out the multiplication sign. So take out the multiplication sign. So I just write it nicely right here. So. And then the 2 here, I'm going to go in front of this right here. So and just take out the multiplication sign. So this is it. So this line is just me rearranging to show them, say, you know, mathematics it. Then when I look at this first term and I look at this second term, I recognize off the bat that something is common. What is common? The e to the 7x plus 1. I'm going to factor it out. I'm going to factor it out. Then, sir, we couldn't write it at the end. You could, but when you factor out something, you put it on the front part first, right? And it really doesn't matter whether you put it at the end or at the front or the back. It doesn't matter because it is associative. 2 times 3 is 6, and 3 times 2 is 6. It doesn't matter. It really doesn't. So when I take out the e to the 7x plus 1 right here, so when I take it out, what is going to be left, sir? 7 times 2x minus 4. See it right here, sir? 7 times 2x minus 4. Sir, I'm following you. Sir, I see it now. When I take out this e to the 7x plus 1, so I'm just going to be left with 2. Watch it. Yes, you're correct. And then if you want to check, you can distribute this e to the 7x plus 1 right throughout these parentheses, and you should get back the same thing up top here. So then this e to the 7x plus 1 not change. See, it not change. See, it not change. What changes is that I can fix up this. 7 times 2x is 14x. 7 times negative 4 is negative 28. This 2 stands alone because this separator, this addition sign, separates this first term from the second term. So I write back the plus 2. And in this set of parentheses, so you can see that I'm reducing because I had 2 sets of parentheses right here. So I've gotten rid of the inside parentheses. And then I'm going to be left with this piece here. So 14x stands alone. So I write it back.
So I get 26.
Negative 28 plus 2.
Oh, negative. Oh, my decimal.
Right. So I get my 26. And the question done right there. So finito. All right. Now, I'm not even going to ask you to do it. Oh, Rockstone. Oh, Rockstone. I don't have. Oh, Rockstone. All right. I know what we're going to do. We have 5 minutes and we're going to max out those 5 minutes. Do me a favor. 5 minutes. Where are we now? Lord Jesus, help me. On Google Drive. 5 minutes.
You're not to worry yourself.
No, I'm not going over to another teacher's class. Let's go. We're going to write this one. Sorry, I want you to write down the question because I'm going to do it myself here. I don't have the solution to that yet. Y is equal to x squared ln 2x plus 1. Y is equal to x squared. Y is equal to x squared ln 2x plus 1. Y is equal to x squared ln 2x plus 1. I'm going to start. We have a couple minutes. See, another 5 minutes or so to do it. So start for me, please. I will end class.
Do that one here.
No, man, it's a product. The first term is x squared. The second term is ln 2x plus 1.
I'm gonna know the ln one, sure.
Man, that's what we just did. See,
the ln is the same e thing?
No, man, the ln is a natural logarithm. The differential of ln x is 1 over x.
Sir, remember
Yeah, she wasn't in the class when you did it first,
Okay.
sir.
Okay, all right, no problem.
Like, what like that?
Not a problem.
5 to 5.
Okay, so my computer decides now.
Start
to start acting up.
5. What happened? It's that.
You to know Mike.
You know, I hear no story.
I hear about the business, you know.
X squared ln 2x plus 1. All right. So there goes the test. Yes, please. I'm hearing you.
I can't do that, you know, because just reaching back.
All right, no problem. That's fine.
Okay.
So that's why I'm going to work the question for you. I'm going to finish this question. We can end, and then I will send it off as per usual. So let's just go. So that's the question. The question says, I think this is 2018, if I'm not mistaken. The question says, y is equal to ln. Sorry, y is equal to x squared ln 2x plus 1. I'm going to show you something because you see the differentiation of the function, it not change, you know, guys. Trust the teacher on that, no? 1 st. It not change, man. Just work with teacher, man, and develop the confidence that I want you to have. And then now this piece is going to be this piece here. So bam, 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 bam. No, I need to get this into a nice looking color. Bam, bam, bam. All right. So you see what sir do? Sir, write for you which one am I call the first? And
Sir,
which one
you're
am I call
not
the second?
sharing, sir. You're not sharing.
Thank you very much. Thank you very much. Thank you very much. What can I do without honors? All right, let's go. There you go. So I have what I have for you here is the question. I have the question, and then I am identifying which one I'm calling the first and which one I'm calling the second, right? So when I'm differentiating, it's going to be the first times the differentiation of the second plus the second times the differentiation of the first. You know, let me just do something like this. And oh Lord have mercy. All right, yeah, let me just go ahead and copy. And I can fix it up.
Sir,
Yes,
the
honey.
ln the part of the second, right?
Of the second, yes.
Okay.
Because you see, it's when you write ln x, the function has to come after the ln. So in this case, x is going to be 2x plus 1. In this case, x is 2x plus 1. So the question says the first, so we're going to write the first. We're writing at the first, and the first is x squared. The first times the differentiation of the second. When I differentiate ln x, the differential of ln x is 1 over x. Talk truth.
Yes, sir.
Right. So it's going to be, if only I can find my multiplication sign. So it's the first times the differentiation of the second. Now, when I differentiate the second, when I differentiate ln x, it's going to be 1 over x, which is going to be 2x plus 1. Remember, 1 over x is, the x is going to be that. And then now, I have to times it by the differential of the function itself. What is the differential of 2x plus 1?
2.
2. And then now I'm going to plus it, plus the second, which is 2x plus 1, ln 2x plus 1, times the differentiation of the first. And when I differentiate the first, I'm going to get, you tell me.
2x.
So look at that and tell me if you agree with me. So it's going to be the first, see it here, so, times the differentiation of the second. The differential of ln x is 1 over x. See here? See, ln x, x in this case is 2x plus 1, is going to be 1 over 2x plus 1. But I now have to differentiate the 2x plus 1. When I differentiate 2x plus 1, I'm going to get 2. So it is times 2 plus the second plus ln 2x plus 1 times the differentiation of the first. When I differentiate x squared, I'm going to get 2x. If not, differentiation, don't write this up. The differentiation ends right there, so. The differentiation ends right there. So let me just be consistent and just put that sign right there because I want you to see what is happening. The differentiation ends right there.
So, sorry, you have something doing from 7 to 9?
7 to 9 tonight?
Yeah.
Oh, you don't have a class?
I don't really call it a class, you know, sir. So.
Okay.
Sir,
yeah.
have a good evening. We have a class from 7 to 9, sir.
Yeah, so I have a report that I must finish off between 7 to 9, but Roxanne, 7 o'clock on. I'll just finish off this and then go. So look at what is happening here. So this is going to be the first, which is this first, x squared, which is right here, so, times the differentiation of the second. So I'm multiplying by the differentiation of the second. When I differentiate the second, the differential of ln x is going to be 1 over x. See here, ln x, remember, you know, all of this is x. Everything that is contained in the parentheses after the ln belongs to the ln. Everything that contains in the parentheses after the ln belongs to the ln. So it's going to be ln x. So it's going to be 1 over 2x plus 1. But remember, I must now differentiate the function. I must now differentiate the function. And when I differentiate the function, I'm going to get 2. Then plus the second, see the second here, ln 2x plus 1. See it right here, so ln 2x plus 1 times the differentiation of the first. And when I differentiate x squared, I'm going to get 2x. So differentiation ends right there. What sir is going to be doing right about now is to fix it up. That's what sir is going to be doing, fix it up. And how does sir fix up the stuff here? Sir is going to say, I can put that in parentheses. I can call this over here and put that as 2. And I'm actually typing while I'm speaking so that when I'm finished, you can see what sir has. And look at what happens here now. So I am using this 2 to multiply this x squared to give me 2x squares. And of course, that 2x squares is going to be multiplied by 1 over 2x plus 1. See it right here. So, and then the plus sign, remember the plus sign is my separator. Don't confuse this plus sign and turn it sideways, or turn your head sideways so it looks like a multiplication sign. Don't turn your head sideways and call this addition sign a multiplication sign. And then all of this now becomes another term. So this 2x is just going to be placed in front of my ln 2x plus 1. So this here is just a simplified version to this. What can I factor out? What is common here that is common there?
2x plus 1, 2.
No, it's just a 2x. It's just 2x alone that is common. Right? And what is going to be left is going to be x. Let me just leave that hand in. I'll do it afterwards. Right? So I'm factoring out my 2x. I'm factoring out my 2x. 2x is common here. 2x is common here. Sir, but the 1 over x plus 1 not common, or the 2x plus 1, the 2x is not common enough. I can't go inside of something. I can't go inside of this and take out the 2x plus 1. So it's only what is in front I can take out. The factor. Remember, I can only remove the factor because I'm factorizing. All right? So when I take out the 2x, I'm going to be left with x right here. So because this 2x times x gives me 2x squares, and this 2x times this 2x rather times this 1 in front of the ln gives me this 2x. All right? So what I can do, copy, I can press equal. What I can do is to say, that, just to make it a little bit more nice-ish, presentable-ish. I can then now use this x to multiply this 1, because remember this x is x over 1. So the numerators multiply together, and then the denominators multiply together. So this x times 1 is going to be this x here, and this 1 times the 2x plus 1 is going to be this down here. And then I'm going to have my ln 2x plus 1, and this will be my final answer. So look at this for me, please. One last time, and then we'll say our good nights. So the question says, and you see, this was 4 marks, you know, and we did this question in about 5 minutes, right? Watch me. Spotlight it. Watch me. The question says, y is equal to x squared times ln 2x plus 1. The question asks me to differentiate. When I'm differentiating, I must know which of the rules that I'm going to be using to differentiate. I must identify what form the question is in so that I can apply the correct thing. Can I use a quotient rule? No, sir. Why not? Because it is that you're not dividing anything. Okay, very good. Can I use a chain rule? No, sir. Why not? Because the terms are not separated by either addition signs or plus signs. Okay. So, sir, it has to be the product rule. Absolutely. Then, sir, which one is the first and which one is the second? Look at the screen. I am calling my x squared the first, and I'm calling my ln 2x plus 1 the second. Then, sir, all of this is one term by itself? Absolutely. All of ln plus, remember, you know, when we speak about ln x, x can be anything. X can be a linear function, it can be a quadratic function, it can be a cubic function, it can be an exponential function, it can be anything. All right? So it's the first and the second. So when I'm differentiating, watch me. 1 minute without moving your eyes from the screen. The first, write it back, times the differentiation of the second. When I differentiate the second, it's going to be the differential of ln x is 1 over x. 1 over x. So we find x come after the ln. So it's 1 over everything right there. So bam. Times the differentiation of this piece here now. When I differentiate 2x plus 1, I'm going to get 2. The first one done. Plus the second. When I call the second, I write him back. The second, present. Put him back. ln 2x plus 1 right here. Times now the differentiation of the first. When I differentiate x squared, I'm going to get 2x. the differentiation done right there. So the first times the second plus the second times the first. The first times the differentiation of the second plus the second times the differentiation of the first. Differentiation done right is in a blue. I need to fix it up. What is common in the first term, that is common in the, but what I did in the fixing up part is just removing these signs. So this 2 is going to be multiplied by this x squared. So I just put it right here. So, and this 1 over 2x plus 1 is, I just contain it in some parentheses so it kind of look nice-ish. And then this 2x, I just put it in front of my ln, and then right by my ln 2x plus 1. And then what I'm going to be doing now is looking right in this first term compared to the second term and see which one of them favor. So I say 2x favor 2x right here. So because the two of them favor, I'm going to take them out. And then what is left has to be x. How you know, sir? Because 2x times this x gives me 2x squared. True, sir. And then I'm going to put this back 1 over 2x plus 1 because there's nothing common. So I'm going to, very special. So I'm going to put back the special term. And then because I take out the 2x, all of it come out here. So there's going to be 1 that is left. And that 1 now is going to be multiplied by the ln 2x plus 1. So this is even a simplified version compared to here because I factorized. But what is left here now is that I can fix up, instead of having, let me just put something else here. Normally when I have more than one set of brackets, I use 2 different sets of brackets to signify what is happening. So let me be consistent. All right. So what is happening here now is that I'm going to be fixing up what is on the inside. How do you fix it up, sir? How do you fix it up, sir? I fix it up by saying x times 1. Remember, this x is x over 1 in all. Any whole number can be written as a rational number. Any whole number can be written as a rational number by putting it over 1. But sir, when you divide it by 1, you're not going to get the same number? Absolutely. But we just assure you that the same something. So the x here multiplied by the x here to give me this x. And 1 times 2x plus 1 is the same 2x plus 1. Plus my ln 2x plus 1. There's nothing more that can be done inside here. So question done. Question is finished. All right. Now, as I said before, this is just an addition, an extension rather, not addition, but an extension to what it is that we're doing for our differentiation. So I introduced you to differentiation, the different rules: quotient, chain product, power rule, right? And then now we have been doing a lot of differentiation with the 4 different types of rules. And then tonight I introduced to you the exponential function and the logarithmic function. Then after that, now come whenever it is, we're going to talk about the square root function. And then after the square root function, I think that is it. Just questions. Oh, not quite. And then I'm going to have some implicit differentiation to do for you, but that's fine. So after the square root function, I'm going to finish with this differentiation stuff really, and then I'm moving to some implicit differentiation with you. Started writing some questions, don't reach much further than number 2. No, number 3. Right, don't reach much more further than number 3. All right, but that's all that there is to it. There's nothing more, I promise. Please now, guys, as I wrap up, yes, please go ahead.
The exam, how is it? I don't know if you spoke about it before class.
All right, so yeah, that's where I'm going actually. What I'm going to say to you is, okay, so what I'm going to suggest to you is go back and look at your recording, the recording in particular for last week, Thursday.
Yeah, I'm talking about the
mid-semester.
How is it? How we're going to do it? Where we're going to do it? Platform and how?
Educasoft, and we have 3 hours on Thursday. So I'll use the first hour to show you exactly what is going to happen, just to give enough time for people to get in and get settled. Then we start the class. What I may do.
Never use that yet, sir. Educasoft.
Don't worry about it, man. You're good to go, man.
Okay.
You have to worry about it. I'll do some orientation next week. What I may do, because we have been doing quite a bit of work, I am not worried that I need more time to complete the syllabus. That's not my concern at all. it depends. I may just end class, and I said may. I may have a change of heart. I may just end class after the mid-semester on Thursday, because I think I'm way too excited to start marking. So what I may do is after the mid-semester, depending on how much time that is left, I know the time that we start, what I may do is just go ahead and just give you some questions to go and work in class, play around with while I'm there, but I don't know. I pray about it. Please, my final thing to you, students.
May the Lord give you grace.
Not only that, the peace that passeth all understanding is going to rest upon you. Now, we need to use prudence in what it is that we are doing. And what is Sir saying? Go through the recording that we did on Thursday. Make sure you understand the something in the something then. And you see, once that is done, I guarantee you, you will be fine. But those of you who are struggling, you still can pull through the course, go through the recording. I don't know what else to say to you. Honestly, I really don't know what else to say to you.
One more time, go through the recording.
Go through the recording and you're good to go. Have a wonderful rest of the evening. That's all.
All right, sir, remember the question.
Yeah, man, we'll do. Best of, yeah, man, all the best.
Remember Microsoft too.
To take out the something them, yeah, man, geez, them reports are killing me, I'm not like to you, but I'm going to do it. But sure.